So in the last video we learned about how to answer idempotent queries in big of one time, but one thing also we learned that we can't answer some queries which are non-idempotent queries in big of one time, right? So how to answer non-idempotent queries using sparse table? Okay, so we'll start with an example. Let's say you have to calculate sum from L to R. Now the idea for answering non-idempotent queries are the same as what is the basic purpose of using sparse table. We will convert this range r plus n minus 1 to binary ranges, sum of powers of 2, ranges that are sum of powers of 2, and then we'll add the value for each ranges of those in sparse table, right? So how to answer non-idempotent queries? Okay, first thing I want to say that our table was of dimension n log n, right? N was here because for you are starting for each index, starting from each index we are storing ranges in powers of 2, and this was log n because in an array of size n the maximum range that can be asked in a query will be n, and n is nothing but 2 power log n, right? So our table ij add value from I to 2 power j minus 1, right? So to answer query sum L to R, what we are going to do is let's take a variable sum equals to 0. Then what will you doing, we will iterate from log of n to 0. The reason why I am using log of n to 0 is because I want to cover the biggest ranges as soon as possible, so that I can break out of the loop. I don't have to iterate actually to all of these values, right? But anyway, so what we are going to do is we are going to check if let's say iterate j, right? Let's say iterate j from log n to 0, and we are going to see if my L plus if L plus 2 power j minus 1 is less than equals to R. That means my this means that my table Lj actually is a valid range. Not only valid range, but also this range lies somewhere in between this index. This index lies somewhere in between L to R, right? So what will I do, I will add this value sum plus this value to my result, and I'll move my L to the next index, which is j. So and at the end, so I will add this value and move my L forward if and only if this is true. Otherwise, if this is greater than L, this becomes greater than R, that means I'll know that my 2 power j range will take me beyond R, which I don't want, because I want result in within from range L to R, right? And at the end I'll return sum. So this is a easy query. So let's start coding. I have used the same examples here, and here are 4 queries, and I'll take L and R input for each query and answer range sum query. So let's take a variable sum equals to 0, and for int j equals to k to 0. Why k? Because initially my k was ceiling of log 2n plus 1, right? That's what was my dimension of sparse table. if L plus 1 power j, 2 power j minus 1 is less than equals to r, that means if my end index lies within the range, then what I am going to do, I am going to just simply add the value, some table value, and move my pointer at the next index. Next index should be our this index was this sum was for, this value was for L to L plus 1 2 power j minus 1, right? So next value will be L plus 2 power j, and at the end I'll return sum. So if I run this, okay, you can see 2 to 5 is 17, 2 to 5 is 17, okay, okay, 1 to 7 is 61, right? So in the next video we'll be solving some practice questions. So I'll see you guys in the next one.